Welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 2034, stock price fluctuation. You are given a stream of records about a particular stock. Each record contains a timestamp and the corresponding price of a stock at that timestamp. Unfortunately, due to the volatile nature of the stock market, the records do not come in order. Even worse, some records may be incorrect. Another record with the same timestamp may appear later in the stream, correcting the price of the previous wrong record. Design an algorithm that updates the price of a stock at a particular timestamp, correcting the price from any previous records at that timestamp. Finds the latest price of the stock based on the current records. The latest price is the price at the latest timestamp recorded. Finds the maximum price of the stock that has been based on the current records, finds the minimum price of the stock has been based on the current records, and we want to do this implementing the stock price class, which is going to initialize itself by calling stock price, and it's going to have an update function which returns void, which takes a timestamp integer and an integer price and updates the price of the stock at the given timestamp. We'll also have a current method which returns an integer, which is the current latest price of the stock. We'll have a maximum method which returns the integer representing the maximum price of the stock, and we'll also have a minimum method which returns an integer representing the minimum price of the stock. So now that we've read the question prompt, let's think about how we might solve this. So we read the quite long question prompt, and now it's time to think about how we might solve this problem. Let's break this down to the simplest possible solution for this. And let me just change my pen to a color you can actually see. Let's use green here. So let's assume that the prices weren't actually messed up, right? Let's just assume that it was just a stream and all the prices were in correct numerical order. All we would need to do is just map each timestamp to the price. And then what we could do is just maintain two variables, maximum and min, to keep track of the minimum values. Simple, right? Unfortunately, with this problem, we don't have that luxury because the prices can be corrected after the fact, right? We could get a price which updates a previous timestamp. So doing any sort of maximum would be very difficult, and we essentially just need to, if one maximum gets updated and it's actually not as high, then we need to find the next largest one. So we can't just have a single element representing our maximum. We have to basically keep a list, and then when the largest one gets updated, we have to update it, our maximum. So what we're going to do is we're still going to have a data structure which maps the timestamp to the price. And this part's relatively easy because we just, every time we see a new timestamp, we just put the price there, and that's all we need to do. If we see a new timestamp that already exists, then we simply update the price at that timestamp, no problem. So this part still stays the same, even though we have our weird kind of volatile market data that comes in wrong at different times. What we want to do with the maximum and the minimum, like I said, we can't maintain a single variable anymore, because say the maximum was like a price of 14, and then actually and this occurred at timestamp 2. Well, what happens if we get an update for timestamp 2 and it was actually only $7? Then this is no longer the maximum, and if we're just storing a single variable, we have no idea what our next one is without going through the entire dictionary, which is not efficient. So we need some way to basically get the next largest value, and then similarly for the minimum, the next smallest value. So the data structure that we actually want to use here is going to be, we want to use a max heap for the maximum and min heap for the minimum. So what's going to happen is that when we do an update to a price, if it happened to be that price that we're updating for that timestamp was actually the previous maximum or the minimum, then we need to start popping elements from our max heap and our min heap such that the new top of the heap is actually our, new price. So we need to get rid of that old price and basically rejig our max heap and our min heap such that the new top is now the actual maximum. So that's what we want to do. And that's really all we need to do for this question. The only change that we have to make from our kind of simple world was that we need these max heap and the min heap. So let's go over to the code editor and write this up, and we'll walk through line by line what you do for the actual maximum and the minimum part, because it is a little bit confusing, but once you see it in code, it should become really clear. So I'll see you back in the editor. We are back in the editor. Let's write the code here. So in the init function, we need to define a few data structures that we're going to use for our solution. So let's do that. So we need to keep track of the timestamp and whatever price is occurring at that timestamp. So we're going to say self.timestamps, timestamps. So this is going to be an empty dictionary, and it's going to handle that mapping. For our current method, what we need to do is we need to know what the last price that we've seen is, and we essentially need to just return the value for that. So we need some sort of variable to keep track of the most, basically the greatest timestamp that we have, because that's the most recent price. So we're going to say max time is going to be equal to 0, because that's the maximum timestamp that we've seen. And remember that we need a min and a max heap to keep track of the maximum and minimum values. So we're going to say self.min heap. It's just going to be an empty list. And then self.max heap is going to be a empty list as well. So those are our data structures that we're going to use. Now let's do the easiest one, which is simply the current method. When all we need to do here is simply return self.timestamps, timestamps, and of whatever the maximum value we have for the time, which is going to be our most recent price. So we're going to say self.max time. So that's all we need to do there. Relatively simple. Let's do the update function, because it's also one of the simpler ones. So remember that when we call the update function, either we're defining a new timestamp price key value pair, or we're correcting an old value. So what we want to do is we want to update the price for that timestamp. So either it's going to exist, or we're just going to add it to the dictionary. Either way, we can do that in the same command. So we're going to say self.timestamps, self.timestamps of timestamp, I cannot type today, equals price. And now we need to actually check whether this timestamp is the most recent time. So what we're going to do is we're going to say self.maxTime is going to be the maximum of the current max time and our current timestamp, in the case that this new timestamp is actually our most recent timestamp. Now what we want to do is actually update our min and max heaps. So we're going to say heap, heap q.heap push, and we're going to push onto the min heap the price and the timestamp it occurred at, and we need to know the timestamp for the maximum and the minimum later. And we're going to do the same thing for the max heap. So we're going to self.max heap. And in our case, we're actually using a min heap because that's the default heap implementation in Python. We're going to use a min heap as a max heap by simply just using a negative value for the value that we sort the heap by. So we simply pass negative price and timestamp. This is much easier than actually using the max heap API, because some of the commands are hard to find, the documentation is a little bit sparse, and it's much easier to just use the standard min heap but use negative values. Anyway, that's the update function. Now what we need to do is we need to actually handle the maximum value. So this is where it gets a little bit tricky, because we can update values, but notice that when we update, we don't actually sift through the heap to make sure that old values get updated correctly. So what we need to do is basically we need to check whether or not the maximum value of our heap actually corresponds to the current price for that timestamp. So let's do this kind of line by line. So we're going to say the current price of whatever the value at the top of the heap is, and the timestamp it occurs at is going to be whatever the current maximum of the heap is, right? So we're going to say heap q.heap pop. So we're going to pop from our max heap, self.max heap, and we're going to get our current price, and we're going to get our timestamp. Now, if the price in our self.timestamps actually equals the current price, then we're okay, because we know that we haven't updated our price, and therefore this is still the valid maximum. But if we've had a correction in our data then this price is actually no longer the correct one. Because remember, in the update, we actually didn't correct the heap. We're actually going to do it when we call the maximum. So what's going to happen here is we need to check whether or not this current price actually equals to the price that we have for that timestamp here in the actual timestamp dictionary. So we're going to say while the current price, and remember that we're using a min heap to represent our max heap, and all of our values are negative. So we actually need to say minus current price to basically undo the negative. And now we need to compare it with self.timestamps of what? Of basically our current timestamp, right? So while these are not equal, then that means that if this is not equal, then all of the insertions that we did based on this being the actual maximum price are incorrect. We need to remove them and now reinsert them into the heap, because this current price, if it's been updated, that means that this is no longer our maximum, and then obviously any insertions that happened after it will not be correct. So we need to rejig the heap because the order is now incorrect. We could have a different value that should be at the top, but because it was getting inserted assuming that this current price was actually the maximum, we need to redo it. So that's essentially what we're doing here. So let us do that. So we're going to say we need to basically update that for all the prices in our heap until we converge to a point where we actually have the maximum. So while, the current price doesn't equal what we have in our timestamps dictionary, what we want to do is we basically just want to pop from the heap. So because those prices are no longer valid. So we're going to say cur price and timestamp equals to heap pop. Oops, heap q dot heap pop. So we're just going to keep popping from the heap until we have that convergence in the prices. Now, when we actually do have the maximum, now what we want to do is actually update our heap with the correct value, and this way we can be sure that it's correct. So we're going to push onto the heap push. So we're going to push onto the max heap. And this time, remember, because we're popping cur price, and this is already negative, so we don't need to double negative it. So now all we need to do is simply just update, so cur price and the timestamp, and now we'll actually have the correct value at the top of our heap. So now all we need to do is simply return the minus cur price, because again, cur price is negative in this case, so we just need to undo the negative to actually return the maximum. So that's how you get the maximum, and the minimum is going to be basically the exact same thing, except for obviously this time we're finding the minimum, so we can basically just rewrite the same code. So cur price timestamp equals heap q dot heap pop self dot min heap, and again we basically want to say while the current price does not equal to the value that we have for that current timestamp, we want to basically rejig the heap so that way that all of our our heap is actually in the correct order. So we're going to look up the timestamp here and make sure that they're equal. If they're not, then again we just do cur price and timestamp equals heap q dot heap pop. We're going to pop from the min heap, and we're going to do that while the current price does not equal to the price inside of the actual timestamp dictionary. And then at the end, again, we just need to actually add our value back into the heap to give us that actual correct value as the minimum. So we're going to say heap q dot heap push onto the min heap, and we're going to pass in the cur price and the timestamp. And all we need to do now is simply return the current price, and that will give us the minimum. So let me just run this, make sure I haven't made any bugs, because there's quite a bit of code here. And oops, this should be does not equal, and that, okay, cool. Let's just run this again. All right, cool. Looks like we've got it this time. Let's submit this, and after this runs, brilliant, our solution is accepted. So that is how you solve this problem. That's the code, but obviously we're also interested in the runtime complexity. So let's take a step back and walk through the runtime complexity for basically all of the methods here, because obviously this is one of those questions where each method is going to have its own runtime complexity. We solved the question. Now it's time to actually talk about the time and space complexity. So let's just make some comments here. So what is going to be the time complexity? Well, let's go through the methods one by one. So we'll start with the update one. So what are we doing in update? Well, we are inserting a value into a dictionary. So this is going to be big O of 1 time. We're taking the maximum of 2 integers. That's going to be big O of 1. And then we're basically pushing onto a heap. So to basically insert an element into a heap is going to be log k time, where, you know, k is the number of elements in that heap. So that's going to take, you know, log k in the worst case for the update, right? We do 2 heap pushes, so technically it's 2 times log k, but asymptotically it's just log k. So we have the current method, and all we're doing here is just returning the lookup in a dictionary. So obviously this is going to be big O of 1 because we're just looking up a value in a dictionary, and that's going to be big O of 1. Okay, so what about the maximum, right? So in the worst case, you know, what are we doing here? So we're popping from the heap. Popping from a heap takes what? It takes, you know, log k time. Why? Because we can get the element, but we also need to rejig the heap. And to redo the heap, it basically takes log k time. So since we could potentially have to go through basically the entire heap down to the last element, where basically the current price equals the price of our timestamp, you know, we could potentially have to do that n times, where n is n minus 1 time, where basically n is the number of elements in our maximum heap. And remember that each pop is going to take log k. This is going to be n times log k for the maximum, where k equals number of, or yeah, actually, sorry, it's k log k, where k equals number of elements in heap. Cool. And then the minimum is going to be the same thing because we're just doing it with the maximum. So we're doing the exact same thing that we're doing at the maximum, except we're just looking for the minimum value. So it's going to also be k log k. What is the space complexity? Well, obviously we have the dictionary timestamps and our min and max heap. And the number of elements we end up storing here is just going to depend on the number of elements in our stream. So we'll just call it big O of n, where n is the number of, I guess, distinct timestamps we store. So that's pretty straightforward there. So that is going to be your time and space complexity for this algorithm. Not the most complex question. I think the only hard part is getting the maximum and the minimum values, because we have to basically update them when the price is incorrect. But once you realize that you want to use a min heap for this, the only hard part is just figuring out how to actually cleanse the heap when you have incorrect values as your maximum and minimum. Otherwise, pretty straightforward question. Anyway, that's enough blabbing. If you enjoyed this video, please leave a like and a comment. It really helps me out with the YouTube algorithm and helps my content reach more people. If you want to see more content like this, please subscribe to my channel. I have a lot more videos on the way, and you definitely don't want to miss those uploads. Otherwise, thank you so much for watching this video. Bye.